In this video, I am going to go over IGCSE Marine Science 5.1 and 5.3 about the open ocean and adaptations to living in the open ocean. This video here is made for my class, but if anyone can use it, you're more than welcome. Everything here is 100% non-profit, and any mistakes here are mine and mine alone. Let's go. Here we get to a lot of the fun part of marine biology and marine science. We have to look at the different marine ecosystems, and we're going to be looking at quite a few ones, both the coastal ones and this case here, the open water one. But we have to look at here the open water ecosystems, and in general, they are less affected by human activity than the coastal ones. Also, we tend to see a higher productivity in the coastal ecosystems compared to the open ocean, mainly due to the carry-off of nutrients we'll see close to the coast, and also the upwellings we'll see close to the coast. It's really a game of the amount of nutrients, and the amount of nutrients powering our primary production, and thereby powering the food chains. And even though the open ocean is a huge part of our planet and our oceans, a lot of them has a quite low productivity due to there's very little nutrients available to our primary producers. As always, when we have a new chapter in marine science, there is a lot of vocabulary, and the two words we have to focus on here is pelagic and benthic. Pelagic is everything in the open water, and benthic is everything at the bottom or very close to the bottom of our ocean. So when we look at the open ocean, the different zones are defined by how much sunlight they get. When we get to the coastal zones, they'll also be defined by the substrate and the type of coast. For example, rocky coast, sandy beaches, mangrove forest, and so on. But out in the open ocean, the main definition of the different zones is how much light they'll get. And we will look at the epelagic, the mesopelagic, and the peripelagic zone here, also known as the sunlight, the twilight, and the dark zone. So we're going to have a look at the sunlight or the epipelagic zone here, and it is about from 0 to about 200 meters. Again, depending on how clear the water is. If the water is very turbulent or there's a lot of sediment in it, it has only about 50 meters, maybe even less. So this is the sunlight zone. So this is the zone where there is enough sunlight, so we'll see photosynthesis. And this is, if we do not look at the chemoautotrophs, this is the primary source of producers in our ocean. And outside the coastal areas, our producers are phytoplankton. They are our small microalgae floating in the ocean, and they need sunlight, they need water, they need CO2, and they need nutrients, and to get that, they will grow. And when they're growing, they provide food for the rest of the food chain. In our open ocean here, phytoplankton is often limited by the amount of nutrients. Of course, if we are in an Arctic ocean, it can also be limited by sunlight or temperature. Up here, we have a high light intensity, which also means that there'll be quite a lot of oxygen, as our algae produce oxygen. That also means there's a lot of oxygen for animals who need it. So fast-swimming fish likes swimming here. There is very little pressure compared to what we see lower. And temperature will change a lot during both a day and a yearly cycle. Also, rain will tend to change salinity. When you have fresh water falling on the surface, it can change salinity. So all this gives us a quite varied part of the ocean compared to some of the deeper zones we'll look at later. This is also where we have a very high biomass, because we have our algae here, which also means we'll have our consumers up here. Some of the consumers will, of course, travel from deeper and go up in migration, but we will have a lot of biomass up here. It is sunlight that defines this zone here. And it is the photosynthesis that the sunlight um, provides that defines this zone here. So we will see the plankton up here, both the phytoplankton and the zooplankton. They are super important food for many animals. And that can be like small fish, but you also see huge animals as whales who sometimes will eat krill, these very small crustaceans, which is a type of zooplankton. So when you live up here in the sunlight zone, your eyesight becomes important and your ability to see what you want to eat, but also see and try to avoid predation. So sun eyesight is super important, and predators up here tend to be active. As we descend below our sunlight zone, we get into the twilight zone. In the twilight zone, there's still a little light, but there's not enough light for photosynthesis. There's still some dissolved oxygen, and temperature tends to be more stable as we don't have the fluctuations we'll see at the surface. Pressure will be higher. We now have about 200 to 500 meters of water above us pushing down, so organisms living here will have to be adapted to this kind of pressure. It also means that there is very little or no primary production. It means animals who live down here must live on food that either falls from higher up or they must migrate up there, eat, and go down again. So to live here, you need to be able to also see, maybe. So some of the fish who live here tend to have very big eyes. So even in this low light here, they still have a chance to see. We also see a lot of counter shading, where you will have a lighter bottom. So if someone is looking at you from below, you will have the same color as the ocean above you. So you kind of use a counter shading as a kind of camouflage, not to get eaten. An example here is our deep sea lanternfish here, who actually have what we call photopores that do luminescence. They can make their own light, which can be used for this counter shading for predator avoidance. So in general, we have less biomass here, and the animals that need to adapt to this low light condition with less food, less oxygen, but also more stable temperatures. When we get below about 1,000 meters, we exit the twilight zone and enter the midnight zone. And by this time, there is no light left. Dissolved oxygen is low, temperature is stable and low, and pressure is very, very high. It also means that any animal who live here needs to adapt to this. There is no primary production anymore, except from the few black smokers, but that's outside the syllabus. So species living here, they need to adapt to this cold, dark environment with little food and where you can't really use your eyesight. One of them adaptations we see is bioluminescence, where animals can make their own light. This can be used for attracting mates or attracting prey, or to also as a form of defense sometimes to be able to illuminate the predators. So we see many animals, for example, like the anglerfish, who is able to make its own light down here. Animals down here also tend to be slow moving, both because we have way less oxygen, but also because you have to conserve energy. There is not enough oxygen of food as running around like a tuna close up to the surface. You'll often see animals have a dark brown or black, so not visible due to the light being produced by bioluminescence. And you'll have bodies adapted to high pressure, being soft so they can kind of bend under pressure instead of breaking. Fish like the anglerfish has large backward facing teeth, so if you're lucky enough to catch something, you will hold on to it, you won't lose it. You'll also see that Mate selection is important, um, as it can be quite hard to find a mate. So, in species like anglerfish, for example, the male can attach himself permanently to the female once they found each other, so they won't get lost from each other in the darkness. When we look at the ecosystems closer to the coast, they will be defined by the type of substrate there. For example, is it a rocky coast? Is it a sandy coast? Do we have a delta from a river and so on? But when we are in the open ocean, the zones defined. ah, The benthic zone is the seabed, or very, very close to the seabed. And it doesn't have to be deep. It can also be like close to the coast. It might just be a few meters deep, or it can be the abyssal plain, 4,000 meters down. In general, animals who live here, um, they tend to have the ability to camouflage or burrow. So you can hide yourself from predators. Or also you can hide yourself to make your own predation easier so that your prey doesn't see you. Some invertebrates, they might move around on legs or tube feet. Uh, and also many of them tend to have like a hard, spiny covering on their body to help them protect themselves from predation. What we call the flatfish, we'll see lying on one side, and they have one eye moving during development. So it moves like from here to the side, so they can actually see from the side of the face, so they can burrow themselves down and still have one eye up and to look for predators. Animals like skates and rays also have like a flat surface, which means that they'll fit very nice along the bottom here. So we'll see different adaptations. We'll see other invertebrates who burrow to avoid predation, to hide. Um, all of this, of course, depends on where we are. How deep are we? Are we still within the sunlight zone, or are we further down? Because um, benthic species will also be affected by pressure, temperature, and oxygen, the same as any other species in the ocean.